It's portable, it's easy to use, and it is unbelievably deadly. The FGM-148 Javelin is one of the most well-known anti-tank weapons in the world today, and for good reason. Feared by all those who face it, it is nothing short of a vehicle-destroying monster with a highly impressive success rate over the 20 or so years that it's been in combat. Today we're going to explore the history and design of this iconic missile, break down how its components function as a team, and find out how this weapon is able to single-handedly take down multi-million-dollar modern tanks. So, in the late 1980s, the US Army announced the beginning of the AAWSM program, or Advanced Anti-Tank Weapons System Medium, and awarded the contract to two companies, Texas Instruments for the infrared imaging system and Martin Marietta for the missile and its launcher. The purpose of this program was to replace America's previous shoulder-fired anti-tank weapon, the M47 Dragon. The Dragon had been an effective piece of military hardware, and having a wire guidance system meant that the missile's trajectory could be easily adjusted mid-flight. However, it was time for an upgrade, and the Army was looking for a replacement weapon with better range and reliability. They were also looking to cut down on training time. For as good as the Dragon had been, it officially required up to 10 days of instruction to become a qualified operator, in just the first half of which the trainee would fire 60 missiles of various targets as they learned the ins and outs of wire guidance. After the Javelin's design had been finished and prototypes had begun testing, officials went back and forth over the potential of the program as a whole. A 1991 order from the Office of the Inspector General outlined a couple of issues, namely the cost of the program, which they expected to exceed budget, as all US military programs tend to do, but they were also concerned about the weight of the unit itself, which they believed to be beyond the limit the average soldier would be able to carry for the desired distance, which was set at 10 kilometers. However, these complaints would be largely pushed aside when it became clear just how effective the Javelin was shaping up to be, especially with its first human-fired test launch in 1993. After passing the Army's official evaluation, a small batch was manufactured and deployed in 1996. The following year, after even more minor adjustments, the Javelin was approved by the Department of Defense for full-scale production, and it would soon become clear that the AAWSM program's creation was nothing short of a huge success. So, now let's get into the details of how this thing actually works. The primary reason the Javelin is so destructive is because of its unique missile trajectory. After the operator is locked onto an enemy vehicle and is ready to fire, the missile can be launched either on a direct forward trajectory or it can be fired on a top attack flight profile, bringing the missile high up into the sky before it comes screaming down onto the top of its target, penetrating the place where the vehicle's armor is usually the thinnest before exploding. This spells certain doom for the tank's crew, and if the target is a tank of Soviet origin, this vertical strike has a good chance of detonating the ammunition stored in its autoloader, creating a massive explosion, which explains those videos of T-72 turrets nearly touching the clouds. The way the Javelin achieves this locating, tracking, and detonation is a complex process, but most of the complexity is handled by the system itself, thanks to lots of sensitive built-in technology. At the basic level, the Javelin is composed of three main pieces: the command launch unit, the launch tube assembly, and of course, the missile that carries the anti-tank warhead. So let's start off with the command launch unit, or CLU. These are the sights that the operator peers through in order to identify and lock onto an enemy vehicle. There are several different views available to the operator here, all of which can be flipped to in an instant at the press of a button. The first option is a standard 4x magnification view, generally used during the day when the sun grants high visibility on the battlefield. The second is a 4x magnified night vision view, displaying a thermal picture of the area, making it easier to spot vehicles that may have otherwise been hidden. The third option is a set of 12x magnified thermal sights used for the highest level of precision in either searching for or identifying an enemy. No matter which of these settings the operator is using, once the target has been identified, he can pull the first of two triggers, called the seeker trigger, to switch the system into the seeker field of view, a final 9x magnification thermal view. It is in the seeker view that the operator confirms their target. Once they're ready, they can now pull the second trigger, the fire trigger, establishing a target lock and passing the information from the CLU onto the launch tube and the missile guidance system. There is then a brief delay between squeezing the fire trigger and the actual launch of the missile, after which the warhead is on its way to an unfortunate victim. An important part of the CLU is its refrigeration unit, which cools the thermal detection equipment inside, allowing it to be much more sensitive to temperature anomalies, even to just differences of a few degrees. Now let's move on to the launch tube assembly. In contrast to the CLU, the launch tube itself is pretty straightforward. It serves to house and protect the missile from environmental damage, aided by 2 end caps, as well as sporting a shoulder pad, carrying handle, and an adjustable strap. And finally, there's the missile itself. When the missile is launched, it uses what's known as a soft launch mechanism. This means that instead of fully igniting the propellant and shooting out of the tube at a high speed, a smaller launch motor activates first, sending the missile somewhat gently flying forward a few feet before the main ignition occurs, and the solid fuel propellant sends the missile on its way to its target. Normally, when someone is firing a rocket launcher of some sort, the backblast from the weapon can cause serious harm to anyone standing behind the operator. This soft launch technique takes away a lot of that danger, not to mention all but eliminating recoil. Once the missile is in the air, it will guide its way to the target without further input. This is called fire and forget, and is one of the best upgrades the Javelin has when compared to its Dragon predecessor. Fire and forget allows the crew who launched the missile to move to a more secure location right after firing, or immediately begin loading another missile. The guidance system within the rocket itself is highly advanced and has been subjected to many upgrades throughout the years. Now, we're not going to get into all of the details here, but essentially, while the missile is headed toward the target, it receives information via infrared radiation through its seeker assembly, which it uses to paint a picture of its environment. Each frame is captured by 3 sensors, is processed by the tracking software, which then compares the newest frame to the previous frame, giving the system everything it needs to make minor adjustments and alter course. This stuff is highly advanced, especially considering that in the 64 by 64 pixel array, the missile also has to keep an eye on the target selected by the gunner back on the ground and understand how its perspective of this target changes depending on altitude and distance. Most of this is accomplished through scores of pattern recognition algorithms, making it incredibly accurate and reliable. And all of these calculations are necessary for both possible trajectories that the Javelin can be fired with. If the gunner selects the direct fire option, often referred to as fastball, the missile gets to a height of about 60 meters or 200 feet before it cruises on a direct linear path to its target. The top attack mode, or curveball, sees the missile make a sharp upward turn after firing, reaching an altitude of 150 meters or about 500 feet. It will hold this altitude as it closes the distance with the target before making a sharp turn and then cruising downward at a steep angle. In the final phase of tracking, for both the direct and top attack modes, the missile selects the impact points that it deems most effective, and the warhead detonates as it strikes the target. And it's here that if you were somehow able to watch in super slow motion, you'd see that the collision with the missile results in not 1, but 2 separate detonations. The first is from a precursor charge, a small warhead in the very front that is designed to absorb what's known as explosive reactive armor, or ERA. ERA is an extra layer on top of a tank's main armor that explodes and launches small metal panels to disrupt the trajectory of incoming warheads. This is because anti-tank weaponry is most effective when the charge is able to actually penetrate the armor and not just detonate on top of it. These metal shards can disrupt the missile's path just enough to prevent it from fully piercing the main armor. The first warhead triggers this reactive armor, clearing the path for the main payload, a 20-pound high-explosive tank round, which ensures penetration and therefore destruction. Overall, the Javelin is one of the most advanced and most effective anti-tank weapons on the planet. Its manual describes how to fire it while kneeling, sitting, lying down, or standing with the weapon resting on another surface. The relative simplicity of scanning a target and pulling a trigger makes training on the Javelin pretty simple, and it can also be attached to vehicles, making it highly versatile. Admittedly though, there are a couple of drawbacks. The first of these is its weight. Coming in at just under 50 pounds, or a little over 22 kilograms, it is not light, and this combined with all the other equipment a soldier is already carrying makes it a lot to carry over a long distance. This has been addressed in part by often having the weapon used by a crew of 2. What doesn't really have a solution though is its sky-high price. The total cost depends on the model and whether or not you're purchasing it as an export customer, but for a single unit, the price certainly exceeds $110,000, which is about what the Pentagon paid per unit when they ordered a batch in 2022. Even more expensive than this is the CLU's newest variant, the Lightweight Command Launch Unit, which currently costs a staggering $500,000. This new module comes with a host of new features like a 5-megapixel color camera and GPS-integrated targeting, so the Army is optimistic that the price will drop in the coming years. Understandably, this price is well worth it when the missile is disabling or destroying a tank much more expensive than the unit itself. But as we'll soon see, this wasn't always how the Javelin was put to use. You see, it wasn't long after its production began that the Javelin was put to the test. When the United States invaded Iraq in 2003, the Javelin proved effective against the armor in Saddam's army, including the Chinese Type 69, as well as the Lion of Babylon, a tank born from an attempt to reverse engineer a Soviet T-72. And of course, right alongside the war in Iraq was a second one next door in Afghanistan. However, in Afghanistan, American soldiers didn't see much combat against enemy armor as the conflict quickly became focused around counterinsurgency, but they soon found a use for it regardless. With a good lock, the Javelin could easily target enemy machine gun positions from long distances, say more than 500 meters away, something that other rocket launchers didn't have the range for. It found itself becoming especially useful against enemies firing from the mouths of caves, and the Javelin could get an easy lock on these targets thanks to the cool thermal background, and the direct fire capability could send the missile a fair bit into the cave itself to hit its target. There are also roles that Javelin would play for the next 2 decades, such as in 2016 in Syria, where it was filmed successfully blowing up an approaching Islamic State car bomb. In fact, at one point it was reported that, quote, of the more than 1,200 Javelins fired by British troops, none has been used against armored targets. But the story of this weapon changed forever in February 2022. With Russian battalions lining up on the borders of Ukraine and an invasion seeming imminent, thousands of anti-tank weapons were shipped into the nation about to find itself at war, including the German Panzerfaust, the British and Swedish N-Laws, and of course the FGM-148 Javelin. Javelins had already been in Ukraine for a few years at this point, as they'd been supplied to help assist in the conflict against Russian separatists, meaning there were already plenty of experienced Ukrainian soldiers well prepared to put it to use. When Russian forces began pouring over the border, their invasion was spearheaded by their armored units, a force which Russia has always been revered for. But these tanks, trucks, and armored personnel carriers quickly ran into insurmountable problems. Poor logistical experience was chief among them. Fuel lines were stretched too thin to advance quickly. But even the tanks who reached their destination went for a bit of a shock. Western anti-tank weapons proved to be a near unstoppable force on the battlefield, with the Javelin scoring record numbers of successful hits in the first couple of weeks. US intelligence claims that of the first 112 Javelins fired, 100 hit their targets. That's a hit probability of nearly 90%. Making short work of Russia's toughest vehicles, including the T-72, T-80, and even the fearsome T-90. The only Russian tank that's yet to fall victim is the T-14 Armata, but only because its operational history consists purely of parades. Understandably, Russian crews began fearing top attack weaponry and started coming up with some interesting ways to try countering it, such as a thin metal cage lifted over their roof, but this doesn't seem to be doing much as the number of destroyed vehicles continues to climb as the war goes on. Numbers from Oryx, a Dutch-based intelligence and analysis firm, are quite shocking, showing 1,612 destroyed tanks, 2,126 destroyed infantry fighting vehicles, and 248 destroyed armored personnel carriers. And these records only indicate hits that have visual evidence for confirmation, so the numbers could be even higher. Obviously, the Javelin wasn't responsible for the demise of every one of those vehicles, as there are several different weapons being used for similar purposes in the conflict, but that didn't stop the Javelin from going viral as a symbol of Ukrainian resistance, most popularly seen in the widely known image of St. Javelin, a depiction of a Madonna-like saintly figure, only instead of cradling a baby, as she would normally, she's holding today's featured anti-tank missile launcher. The image became so popular that a mural of it was even painted on the side of a large residential building in Kiev, and it was rumored that the artwork may have been commissioned by the city's mayor. It was also in Ukraine that the Javelin scored its first kill against a helicopter. The helicopter, a Ka-52, was hovering low to the ground and moving quite slowly to avoid detection, allowing the Javelin operator to lock onto it with ease and strike it using the direct fire mode as if it were any other ground target. It's something that hasn't been done before or since, but funnily enough, the tutorial for locking onto a helicopter is actually mentioned in the weapon's manual, and if you're curious, it's on page 27. It's unclear how long the war in Ukraine is going to last, but the Javelin has already cemented itself as a staple of the conflict. The US has increased its demand to replace the missiles it has sent overseas, and its performance in combat has earned it some new customers, with Norway, Albania, Latvia, and Thailand interested in purchasing some. And with more upgrades constantly rolling out, like the lightweight CLU multipurpose warheads and improved missile speed, it's likely to remain an integral part of the US arsenal for many years to come.